Hello students, welcome back to our channel NewtonGATE Academy. In last two videos, we have discussed about reflection of light. You have not seen those videos? Link is given in the description below. Before starting this video, go to those videos and check those two videos and then come back to this one. In this video, we will be discussing about the refraction of light, which is basically the second part of your light chapter. So without further ado, let's start with the video. Today our topic of discussion is refraction of light. So in case of refraction of light, the first thing we need to learn about refraction of light is what is refraction. So we will be starting with that only. So what is refraction? Refraction is a change in the direction of light when it is passing from one medium to another medium. Now remember, in the last video we actually talked about reflection and defined what is reflection. When we defined reflection, we specifically said it is a one medium phenomena. There was no second medium. So light was getting reflected, and the reflecting light, or the reflected light, and the incident ray, the incident beam or incident light, whatever you want to say, they both belong to the same medium, but it won't be same in case of the refraction. In case of the refraction, there are two mediums. In one medium, the incident ray is belonging, and then there is a surface which will be known as refracting surface. After getting refracted, the direction of light will be changed, and that phenomenon will be known as refraction. And after getting changed, it will be belonging to some other medium, the second medium, and that ray will be no longer known as incident ray, rather it will be known as refracted ray. Okay, so along with the definition, we need to remember something else as well. If your light ray, the incident ray, is actually passing as a perpendicular, or rather the incident ray is like this, if this is the refracting surface and this is your incident ray, it is actually making a 90-degree angle with your refracting surface, then there is no refraction that is happening. The light will pass in a straight line. There will be no change in case of the direction of light. This is the only phenomena where no change will be happening. If the angle was 89 degree, even 89.5 degree, 89.9 degree as well, then also refraction will be happening, but only in case of the 90 degree, there will be no refraction. The light will pass, right ray will pass same as it was in case of the incident ray. So let's move into the next point, which is refraction of light. We will be talking a bit deeper into the refraction of light. I said it will change the direction, but I have not mentioned how it is changing the direction. So the first thing we will be talking about what is a rarer medium and what is a denser medium. You remember what is density, mass per unit volume? That is how we will be separating or typecasting two mediums. One of them will be rarer and another will be denser comparative to both of them. And a rarer medium is those medium whose density is smaller than the other media that is involved in that case, and in that case the second media will be the denser, and vice versa. Depending on which two media you are taking, your rarer and denser medium can change. So if your light ray is traveling from rarer to denser medium, so your incident ray is belonging to the rarer medium and your refracted ray is actually belonging to the denser medium. If that is the direction it is following, then the refracted ray bends towards the normal. Now what is the normal? This. When your light was supposed to pass through the 90 degree, it passed without any refraction. That particular line will be known as normal. Just like in case of reflection, we define normal as well. Here also this is a normal. So if I am traveling, or any light ray is basically traveling from rarer to denser medium, it will bend towards the normal. If you are going from rarer to denser medium, your refracted ray is getting bended towards the denser medium. So your incident ray is basically, or rather your incident angle, I should be talking about angle, your incident angle I is more than your refracted angle R. This is not reflection angle or reflected angle, this is refraction angle or refracted angle. This is your refracted angle. if that is the case, so in case of so what we learned here, that rarer to, if you are your light ray is moving from rarer to denser medium, your refracted ray bends towards the normal, your incident angle is much more than your refracted angle. If the situation is just opposite, if your incident ray is traveling from denser medium to rarer medium, then it will bend away from the normal. So in this particular case, what will happen? Your incident angle, which is I, will be smaller than r. In the previous case it was greater than r. In this case, when you are traveling from denser to rarer medium, it is smaller than. These are the two cases, because there can be, if you are taking two mediums, there can be only two cases. One of them is rarer, another is denser. Either you are moving from rarer to denser or denser to rarer. Okay, and here as an example, I had taken rarer medium as air and denser medium as glass. This is the example that I had taken. You can take any other example. The particular theory will remain same. The next thing, why I took that particular example, air and glass, you will understand in this, because there is a section or there is something we will be learning is refraction of light through a rectangular glass slab. So there is a rectangular glass slab and there is a light that is incidenting, and then there will be a light that is coming out of the glass slab, because glass slab is practically working as a refracting surface. Not one, rather two. We will be talking about that, why there is two refracting surface, but it is not opaque that it will form any shadow or something like that. So here your what is happening in case of the if you are taking any glass slab, there are actually two surfaces that are basically getting acting as your refracting surface. So what are the two surfaces? One of them is this one, the one on which incident ray is falling upon. This edge of the glass slab will act as a refracting surface, and in this case, think about it, what is air? A rarer medium compared to glass. So if your light ray is moving from rarer to denser medium, as we learned just a while back, rarer to denser medium, your refracted ray will bend towards the normal. That is what happening here. Your refracted ray is bending towards the normal. Okay, and now after that, what will happen to the light? If there is nothing else is happening, like no reflection and no refraction will happen within the glass slab, so it will move in a straight line, as we know, rectilinear propagation of light. And after moving in a straight line, what will happen to that light? It will try to come out. Now what is the in this case, when it is actually trying to come out, it is facing an opposite reaction rather than this one, opposite phenomena, because glass slab, this light is acting as an incident light right now. So you are trying to move from denser medium to rarer medium. What will happen in that case? This bending away from the normal. That's what it is happening. It is bending away from the normal, and we are calling it as an emergent ray instead of a refracted ray, because this one is a refracted ray, the in between one. This, not this. This one is the refracted ray. So if this one is your refracted ray, then after getting refracted again, we are calling this one as an emergent ray, the ray that is coming out. So that is how in a glass slab refraction is happening twice. Also we should actually understand or appreciate some phenomena, that if there was no glass slab, your incident ray would have come in a straight line. If you extend that straight line, and the straight line that is or rather the ray that is getting emerged out of this glass slab, these two will be parallel to each other. So basically, after getting refracted twice, your incident ray is your emergent ray is still parallel to the path of the incident ray, but there is a lateral shift. this small difference between the path that incident ray could have gone if there is no glass slab, and the way it is actually gone because of the whole glass slab presentation and the emergent rays path. Actually there is a distance between these two. This distance particularly is known as lateral shift or lateral transition. This is denoted as small d. Okay, this is the whole glass slab concept. Then we will be coming to the laws of reflection. Laws of refraction. Actually, laws of why I said laws of reflection, because the first law is same as laws of reflection. The incident ray, in case of reflection I said reflected ray, here I am saying refracted ray. So incident ray, refracted ray, normal to the interface of two transparent media at the point of incidence or lie in the same place. This is same as before. What is changed? Change is this one. The sign of angle of incidence to the sign of angle of refraction is constant. This ratio is constant. Sin I by sin R, this ratio is constant. Now you know what is sine, because I hope you have done trigonometry by now. So sin I by sin R, this I is the incident angle and this R is the refracted angle. This ratio will remain constant, and this particular relation is known as Snell's law. Snell's law of refraction. It is also, you have to keep in mind, this is true for angle if your incident angle is belonging within 0 to 90. If it is crossing 90, then this is not the correct law, but usually it will belong within 90. So incident angle is belonging within 90 means your refractant angle will also belong within 90, and that is how you can calculate the ratio and check that this ratio will remain constant. Okay. Then we will be talking about something called refractive index. So what is refractive index? Refractive index is a very important physical quantity that is actually relating to relative speed of propagation of light, and we will be learning in some in future that sin I by sin R is basically equal to the, so sin I by sin R is remaining constant. Then also we will be learning the fact that this constant is basically the refractive index. Let us first learn what is refractive index for that. So sin I by sin R is my constant, and this constant will be known as my refractive index. So what is refractive index? Let us learn that at first. Refractive index is a very important physical quantity that is actually related to speed of propagation of light in different media. So you will be learning, or rather we will be learning in some most likely today only, that speed of light is dependent on the media, and it will be changing media to media, or rather it will vary from media to media. So speed of light in different media is different, and their ratio is basically will be known as refractive index. In light is basically first is in the vacuum, and then it is decreasing. In case of the vacuum, it is 3 into 10 to the power 8 meter per second, and it reduces on the glass and water and so on and so forth. Your refractive index will be decreasing only. So let us come to the formula of refractive index instead of going into the vague concept. So the refractive index, in case of the if I am letting it know as this is usually represented by n21, you can write it like this, or you can write it like this, n21, just like that. So the equation form will be speed of light in medium 1 divided by speed of light in medium 2. If that is the case, then I can say that speed of light in medium 2 is V2 and speed of light in medium 1 is V1, then N21, this will be known as V1 by V2. Similarly, if I am trying to find out the refractive index of medium 1 with respect to medium 2, then it will be N12 is equals to speed of light in medium 2 divided by speed of light in medium 1. So what I am suggesting, that if I am saying that you are trying to find out the refractive index of medium 1 with respect to medium 2, then you are supposed to write N12 and the one in which you are trying to find out the refractive index, in that medium whatever is the speed of the light should be in the denominator and the other one should be in the numerator. That is the law that we have followed in both the cases. This is the equation of n21 and n12. Depending on which media you want to find out the refractive index of, you will be using one of them. Then there is something called but let me ask you, isn't it a bit confusing? Like I said refractive index should be a constant, then why I am going for one media to another media or something like that? Could not be there be a fixed parameter or something like that? There is one. If you are considering the speed of light or rather speed of light in the vacuum and or air, vacuum or air, in both the cases it will be 3 into 10 to the power 8 meter per second. You are considering or rather calculating the refractive index with respect to air or vacuum of a particular medium. In that case you can directly find out the refractive index. In generally the refractive index, as you know, is the absolute refractive index, this one, when you are actually suggesting that you are taking one media but the other media with respect to which you are trying to find out the refractive index is either vacuum or medium or vacuum medium or air. Okay, so in that case what will be the formula? This Nm, the absolute refractive index, is equals to speed of light in air divided by speed of light in medium. So speed of light in air is 3 into 10 to the power 8 meter per second. We generally denote it by C, and divided by V is the speed of light. Whatever is the speed of light, you can write that. And here I have given some examples so that you can understand. Speed of light in water is equals speed of light in air and speed of light in water ratio is equals to 1.33. So basically refractive index of the water is 1.33, refractive index of crown glass whereas is 1.52. Okay. Then the next thing we will be talking about is spherical lenses. We talked a lot about spherical mirrors. Now we are stumbled upon spherical lenses. Spherical lenses are basically a piece of transparent glass bound by two spherical surfaces. These two surfaces are basically either convex surface or concave surface. Depending on what kind of surface I am taking, there are two kind of lenses, convex lens or concave lens. Convex lens is this one, converging one, just like we learned. Okay, let's not jump into that, let's stick to this one. This is the convex lens. This one is the refracting surface and this one is the interacting surface. Like light will incident on this, after getting refracted within the lens, it will come out through this surface. Okay, and there is another one that is known as the concave lens, in which this is this is where in this surface all the incident rays incidenting, and then after getting refracted within the lens, it is getting refracted and coming out through this surface. Okay, so in case of the convex lens is basically the one who is a converging lens. It will converge. Now we know what is the meaning of converging. After getting reflected or refracted, if all your rays are meeting at some point, then we call it as converging mirror or converging lens. This is the converging lens because all the rays after getting refracted will meet at one point, that is your focus, and after that it will get diverged in different directions, and this is known as this is why it is known as converging lens. Whereas in case of the concave lens, it is just opposite. It is a diverging lens. After getting refracted, it is basically diverging or rather appearing to be diverged from a certain point. We all know what is that certain point. That certain point is basically its focus itself, but we will be calling this, because of this particular phenomenon, we will be calling concave lenses as diverging lenses. Okay, then we also have to come across some terminologies in case of the spherical lenses, just like in case we came across some terminology in case of the spherical mirrors as well. Some terminologies are still same, like center of curvature, radius of curvature, but you have to understand instead of one there are two radius of curvature or two surface of curvature, center of curvatures. Why? Because there are two surfaces. If I take this one, probably this will be more understandable. Think about this one. This one is one of your convex mirrors. So it has, or rather one of your part of the one of the spheres. It has a radius, it has a center. So it has a center of curvature, it has a radius of curvature. Similarly, this one, this side will also have another radius and another center of curvature. So just because of this, lenses have two center of curvatures and two radius of curvatures, and they are actually denoted by C1 and C2 and R1 and R2. And there is something else that I want to point out, that is optical point. Remember, in a mirror we said the middle point is known as pole. Here the middle point not like middle point of the surface, the middle point here. If I draw a perpendicular, if I am drawing a principal axis is still remaining same, just like before. If I am drawing a perpendicular, the point where it is meeting the principal axis will be known as your pole. Will be known as your optical center. Now O is the optical center, and then we can talk about principal focus, and principal focus will be, in case of the concave mirror, it will be this one. This is the one I have marked already, and here it will be F1. This F2. I probably had marked it as F2. Yes, this will be your principal focus. Depending on what kind of lens you are taking, your principal focus will be different, as we have already defined before. Okay, then there is something that we need to talk about is image formation in lenses using ray diagrams. So when your ray strikes concave or convex lens obliquely at its pole, it continues to follow the path. By pole I mean actually the O, optical center. You can call it by optical center, or you can say it is a pole of this particular lens. It is the first thing. If you are hitting the optical center, you will be passed through without getting refracted. Secondly, when a ray is parallel to the principal axis strike the concave or convex lens, the refracted ray, not the reflected, refracted ray passes through the focus of the principal axis. We know this one. This is actually same as before. And also the third one, when a ray passing through the focus strikes to concave or convex lens, refracted ray will pass through the parallel to the principal axis. These two are actually same as before. These two are same as in case of the reflection and refraction. These two remain same. Only this one is the new one. If your light rays, incident rays passing through the optical center, it will pass without getting refracted. So the first image we will be talking about is image formed by convex lens. The first one is when your object is at infinity. If your object is at infinity, your object will be essentially sending the parallel rays parallel to your principal axis. They will get reflected and they will get refracted and meet at the focus. That is what it is supposed to be. So the image size will be smaller than the object, maybe the point image, we should say, a real point image. The second case is we are keeping the object a bit closer. Where we are keeping it, this AB is my object. Object is closer but not crossing the center of curvature of the first surface, not crossing C1. It is beyond C1 still. So one of the rays will go parallel to the few. I actually drawn one of only one. It will be a few rays will be actually parallel to principal axis. They will actually got refracted and pass through the focus. And the other option is the rays can pass through the optical center directly and it won't get refracted. It will pass through the same direction. So these are the two options. If that is the case, then we can see there is an image that will be forming here. The intersecting point is here, and if I draw a perpendicular from the principal axis, it will be here, and it will be inverted since it is in this direction, not in the erected form. It will be inverted, and along with being inverted, it will be diminished. and also you can see it is like not beyond C2, it is within C2. The third point is when I am keeping the object at C1. If I am keeping the object at C1 and actually following the same rule that few of the rays will be passing through as a parallel to principal axis and go through the focus and meet at some point or land at some point, and another ray will be passing through the optical center and without getting refracted will pass through it directly. I can see that the image will be forming at C2, directly at C2. If your object is at C1, the image that is formed right now is at C2. Along with that, we have to remember that this particular size of the image will be equal to the size of the object. It won't differ. It won't differ in any way. The next thing is we are like closing the object. We are keeping the object in between C1 and F1. If that is the case, again we can see, if I am following the same path, that principal axis is going through this, a parallel ray of principal axis is actually going through focus and another is passing through the optical center, then the meeting point of them, the intersecting point of them is here. So the image that is formed is beyond C2 now, and we are actually forming an image which is much larger than the object. So the image is magnified right now. Then there is another one. If I am keeping the object at focus F1, then what will happen? Then the size of the image will be much larger. It will still be real, but it will be formed at infinity. Then there is only another one in case of the convex lens. If we are keeping the object even closer than the focus, closer than F1, we are keeping the object in between the optical center and F1, then what will happen is, if you do the same thing, that one of the rays is passing through optical center and another one is actually parallel to principal axis and getting refracted at the lens and actually going through the focus, these two won't be meeting, but we need an intersecting point, right? So we will backtrack them and we can see it is actually meeting here, or rather appearing to be diverged from here. So what kind of image it will be forming? Virtual image. This is a virtual image. In this virtual image, it is also like larger than the object, but it is virtual, so it is erected. These 6 are the kind of images that can be formed by a convex lens. Now let us come to the concave lens. What will happen in case of a concave lens? There are 2 cases. One of them is when you are keeping the object at infinity. What will happen? The rays parallel to the principal axis will come, get diverged, and they will be meeting at focus. This focus F1. But what will happen? Also, this will be a virtual point image, not the real one like convex lens. Also, what will happen if I keep the object anywhere? I kept the object in between F1 and to F2 is basically your C2. You can keep it anywhere. If you are keeping it anywhere, what will happen? One of the ray will be parallel to the principal axis, will get refracted and will get diverged. We can backtrack it, it will make it at focus, and the another one will be passing through your optical center. We can see that the intersecting point is here, so the image will be here. The image is diminished and the image is erected, so it is a virtual image. So these are the 2 cases in case of the concave lens. Now we will be coming to something called lens formula. Now and magnification formula, but let us talk about the lens formula first. We talked about mirror formula, remember, which was involving object length, or the distance of the object from the mirror, distance of the image from the mirror, and focal length. Here also we will be talking about a formula that is involving these 3 in case of lens, instead of in case of being in case of the mirror, it is in case of the lens. This 1 by f is equals to 1 by v minus 1 by u is my length formula. So 1 by f means 1 divided by focal length is equals to 1 by v means v is my image distance minus 1 by u is my object distance. This is known as the length formula. Unlike my mirror formula, where actually we had a plus sign, here we have a minus sign. 1 by f is equal to 1 by v minus 1 by u. Also you have to remember it is without the sign convention. You have to check what are the signs of f, v and u whenever you are doing a particular problem. We will be coming to the numerical problem in the end of this discussion. So we will be including those signs here, but the original formula looks like this. After that you will be using the sign of f, v and u in particular cases, and after that we can solve any problem. And along with this we have another formula which is known as magnification. Magnification formula is remaining same, height of image divided by height of object. It is h prime by h, whereas h prime is the height of the image, whereas h is the height of the object. Along with that, we also have to remember there is another formula that is basically connecting height of image by height of object with image distance or object distance, that is v by u. Remember in case of reflection, the magnification formula, this was same, but here we had a minus sign. Magnification was equals to m is equals to minus v by u, but here m is equals to v by u. Remember this one, do not get confused in between these two. Okay, so let us take a example, numerical example. The first example will be talking about is a sum. Let us look at the sum. What is given? A concave lens of focal length 15 cm forms an image 10 cm from the lens. How far is the object? Okay, so they have given me the focal length and they also have provided me with the image distance. Okay, so focal length and image distance, both in case of the concave lens, both will be on my left hand side, right? Concave lens is this. So your object is here. Your focal length, that is the distance between f1 and o, will be on the left hand side. And as we have learned in the last video, that whatever that is on the left hand side will be of negative sign. So now after putting this negative sign, I had just used the it won't be mirror formula, it will rather be lens formula. It will be lens formula, and after that, okay, so this is lens formula, and in the lens formula I have actually used these two values. I don't know what is the value of u, that is supposed to be found out. So 1 by minus 10 minus 1 by u is equal to minus 1 by 15. So after that I just calculated it. I took u on this side and 15 on this side, or you can take this side as well. So 1 by 15 minus 1 by 10, that will be coming out as, if I do the calculation, I have skipped some step. Do not skip the steps, so that is why I will be doing the calculation here for you guys. So what I am doing here is I will be using this one. Okay, so what we got is 1 by u is equals to 1 by 15 minus 1 by 10. So what can we do after this? Take it as 150 LCM, then 10 minus 15, then it will be minus 5 by 150. Cancel it out, it will be 30. So it is 1 by u is equals to minus 1 by 30. So u is basically equal to minus 30 centimeter. If u is equal to minus 30 centimeter, so the along with your image which was belonging to the left hand side, your object will also be belonging to the left hand side. We know that is supposed to be the case, because object should always be on the left hand side, in front of your lens or in front of your mirror. That was according to our sign convention, the first rule in the sign convention, remember? Okay, the second example that I have taken is a 5 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 18 centimeter at the distance 12 centimeter from it. Use lens formula to determine the position, size and nature of the image. So I have asked too many things in this sum. So what I am asking, I am providing you with the object distance, object distance, focal length. These are the two things I have provided, and also the size of the object, 5 cm. Now I am asking to find out the position. So the first thing we need to find out is V. After that we need to find out the size and nature as well. Okay, let us start one by one. Let us try to find out the V first. Also remember, I have set convex lens. So in case of convex lens, though U will be minus 12 because object is always in the left hand side, but your focus is on the right hand side. So what will be the sign of F? Plus 80. So let us put all these values. I have put on the values that minus 12 is your U and F is 18. So I have used some lens formula, 1 by V minus 1 by U is equals to 1 by F. So 1 by V is basically equal to, okay, I have skipped one step. Let me do this one. It is basically equal to 1 by 18 minus 1 by 12. Now you can do the LCM, which is basically 36. Then it is 2 minus 3. After that I have done it. Minus 1 by 36. So V is equals to minus 36. So the image obtained is basically 36 centimeter on the same side of the, not mirror, it should be lens. You are not supposed to write mirror here. Okay. So 36 centimeter on the same side of the lens of the object, because object distance was negative as well. So in case of the convex lens, object distance is always negative. So we have found out the image distance is negative as well. Now let us find out the height of the image. Height of the object was given as 5 centimeter, and we know h2 by h1, which is image height of the image by height of the object, is equals to image distance divided by object distance. So h2 by h1 is equals to v by u. Now I know what is the value of h1, I know what is the value of v, and I know what is the value of u. Let us put all of them. If I put all of them, I will. Okay. So the image that is obtained is 36 centimeter on the same side of the lens of the object. And now let us find out the height of the object. Height of the image. Height of the object is given as h1 is equals to 5 centimeter. Now magnification formula, as we have learned, is h2 by h1, that is equals to v by u. V by u means image distance divided by object distance. So if I try to calculate this one, I am putting all the values, 5, minus 36 and minus 12. Also remember, whenever you are using v or u, use with signs. If it is positive, put positive. If it is negative, put negative. But do not omit the signs. In that case, you will be getting wrong values. H2 is equals to, then I am finding out H2 is 15 centimeter, and thus the height of H2 is 15 centimeter. Thus the height of the object is 15 centimeter. Positive signs means the image is virtual and erect. We have learned in the reflection, when we actually did magnification in reflection as well, if your sign of image or the value that is you are getting of h2 or h1, or rather h2 specifically, you never get negative in case of h1. H2 is negative, that essentially means your image is inverted. That is why you are getting a negative sign. Inverted means real, but here we have got a positive sign, so it is virtual, erect, and virtual and erect object, and obviously enlarged because it was 5 and now it is 15, so it is enlarged.
This is it for today. If you like the content of this video, please like this video, subscribe to our channel and keep watching NewtonGATE Academy. And also don't forget to ring the bell icon for more notification of more such contents. Thank you.